It's officially 10 a.m. It's time to start. We don't have overly stuff together, but it is right to the walls, and I'd like to have a discussion. A lot to talk about, and we won't see each other again for months, right? This is a kind of longer waiting until March. It's not loud because we can go over it. I think my co-chair is evaporated, so Sandy will just step into the co-chair now. Yeah, just lock that door and barricade it up there. All right, you guys in the right room? Right room? Blue sheets, like those rolling around right now. We need a volunteer to take minutes. Who has a watch?
I have Mike said that he's taking minutes.
Mike's doing minutes? You rock.
Because you know why I said yes, because my he would take minutes.
You took my hit. Normally, like, share group, that's perfect. Let's go. Yeah, I'm going to need several of those back to last week. So we have minutes. Jabber, anyone do Jabber Scribe? Anybody on Jabber? We do. We've got 2 people on Jabber, so we're going to need Jabber Scribe. Someone hop on? Somebody. Yeah, someone take your minutes.
Thank you.
Jabber, did you get on Jabber? Yeah. You'll be presenting here in a second. So it'd be kind of tough. But someone's got to manage the questions when they come in. Otherwise, we'll sign it to Tony when he shows up. All right, everyone read the note well? You know your legal obligation when you're here? Do you know what your legal obligations are? No? Me either, but I know the note well. So agenda, we're not totally packed, but I do want to push some stuff along and make room for things we want to discuss, because some of the stuff, I wouldn't say contentious, but this is open issues to talk about, and I'd like this dynamic conversation in the room, which is much better. Hey, Dad's here. Hi, Dad.
What happened to your brother?
We have no idea. We heard he's out there like bolted the coffee, but you make sure you give him a demotion or some sort of like black star for this one. Yeah, there we go. So anything missing from this agenda? I know I got all the slides in. It was kind of funny being the end of the week. People had other stuff as a higher priority, so stuff came in like all the way down to this morning, but we're done. Anything missing? We're solid? Okay. Anything outstanding, like business-wise, other than a bunch of documents in the queue? We've got a bunch of working group last call. We have a bunch we're looking for shepherds. Some are assigned shepherds. And we still have documents that really come, hopefully will be adoption calls. But to help us get through that stuff, Sandy has volunteered to step up as secretary and jump in and help us push this stuff along. This is kind of weird. From here, it goes into holiday week. I'm sorry, we're full. Sorry, sir. Sir, we're full.
One shepherd is enough?
Yes.
No. If it were multicast, sure, one shepherd would be enough. It's not been deployed. So over the holiday, we're going to queue this stuff up. I'm not going to dump everything in your email address because no one's going to read them anyway. But like we did last year, come January, it's going to be flooded. We got to push this stuff through. There's so many things that are dependent. And I feel like we had such great progress, and we're almost to the point of being dysfunctional now. Not because we don't have good work or good people, we just are not, getting these things moved along as we need. So Sandy has clearly saw that it's all our fault, and she's going to jump in and help us make this happen. All right.
Now you have a proper God supervision.
Proper adults instead of the pseudo adults we've had here. Well, my kids will agree. They've always been the adult in our relationship. All right, next one would be here. All right, Sandy's first, right? Blue sheets are out. Are you going to show up and act like nothing's happened while you were gone?
I was testing you.
So your finger goes on this button right here. And when Sandy says ding, push that button. Yes.
At first, I'd like to thank you, our chairs, give me the great chance to take the secretary job. And I'm very glad to work for the working group with our chairs. Thank you. And now let me start my presentation for the Bier prefix redistribution draft. We have many co-authors, include S. Jeffrey, and many others. So at first, let's see the problem statement. We know that it's a traditional network in our deployment. We will deploy many IGP areas across many regions. So in this figure, we just list 3 areas. You will see 2 OSPF areas and 1 core areas. Core area. But we know in some situations we will deploy different routing protocol in different regions because some administration requirement. So in this draft, you will see we may deploy ISIS in the core area too. So we know that the unicast function works well because the ABR, area border router, will do the redistribution work to redistribute the prefix across many areas. So the unicast works well. But if we'd like to deploy multicast in these networks, we can use the PIM protocol to do it. And it works well because it's not depends on the, it only depends on the unicast routing calculation result. So, and we know that in these networks, maybe in some areas, just for example, these areas, there are not too many routers in the area. It's just less 10 routers in the area. So, and the same with the other areas. So, if we'd like to deploy PIM in this network, it's no problem. But if we'd like to use Bier to replace PIM in this network, we will face some problems. Let me explain it. Because we know that from the existing standard draft, the Bier is related to the IGP areas. So every IGP area will become a Bier domain. So in this figure, we will have 3 Bier domains. It's just a part of the networks. So, only we see the ABR, the R3 and R4 will do the overlay signaling work and the encapsulation and the decapsulation work as well. So we will know that many Bier encapsulation and decapsulation functions will lead to the inefficient forwarding. So we'd like to improve the efficiency of the network. So we want to build a large Bier domain through all these areas. So we can remove the state management in the area borders, and we can eliminate the encapsulation and decapsulation functions from the ABRs. So we will improve the Bier forwarding efficiency. But the problem is, how can we achieve it? So just as my side, the Bier domain is related to the specific IGP area for now. So we'd like to deploy the Bier across many areas. So we know that when the ABR does the prefix distribution work, we can also redistribute the Bier info. information, such as the BFR prefix and the BFR ID and the other associated information. So the Bier node information can spread in the whole Bier domain and across multiple regions, areas. So at first, we can use the advertisement aligned with the existing IGP and BGP definition. So when the prefix advertised across IGP area one by one, we can also carry the Bier information with it. And as well as the MPLS encapsulation, you can also advertise it because though the Bier encapsulation has local significance, but we may use it across different areas. So every node in the domain can build the Bier forwarding plane, and the several IGP areas will be merged into one Bier domain. So, but as we know, when the ABR does the unicast prefix redistribution work, some summarized or default root or aggregated function can be used. So, when the default root, for example, when the default root is used, only one prefix will be advertised into another area. So, in this situation, it will hide many BFR prefix. So if we'd like to advertise the associated BFR IDs with the default root, we must need a new extension for it. The new extension is that we can carry the associated BFR IDs all set and advertise it into the other area. So we can achieve the goal that advertise BFR prefix and the other Bier information associated with any type of prefix. So that's all I want to share. And this draft has been present 3 times, if I remember it right. So we'd like to call for working group adoption.
Jinrong from Huawei. Just one comment. I think the scenarios and the requirements raised by this document is useful. But the document and the slides just the last before this slide says that the BFR ID imported from outside the area is advertised with the summary root. I think this should be a host prefix because not only the RFC 8401 requires that the Bier information is advertised with the host prefix, but also the Bier architecture RFC make it clear that the Bier information should advertise by an IP address. That's a host prefix. That's the same meaning as a host prefix. So I think, so my comments is that information proposed by this document should be advertised with the host prefix. So that's my comment.
Let me explain it. One, the host prefix just mentioned by Jinrong can be advertised across different areas one by one. Or, of course, the host prefix and the associated BFR IDs can be advertised in the same time. So it's the first solution for it. If you do the prefix advertisement one by one across the IGP areas, you can do it. But if we want to use default or summarized route to across the many areas, we must use some other method to do it. So we impose the new extension for it. This two solutions can be used together. So you can, if you only advertise the prefix one by one, you can only use the existing advertisement for it. But if you would like to use the summarized or default route for it, you should use the other method. Otherwise, you can't carry the BFIDs, right? Okay.
Human Bitcoin Nokia. Yeah, this is definitely an interesting problem. One thing I can't get my head around is that when it comes to the summarized route or even the default route, are you proposing that the ABR going to track all the BFRs or BFIR for that matter on one area, and we're going to create this TLV with all those BFR IDs and shoot it to the second area? Like, I'm not sure if I understand how you're proposing a summary route will advertise all the BFR IDs in your core area into area 1 or into area 2, because you need to advertise an entire list of BFR IDs if it's a summary route, right?
Let me explain it. Because we'd like to merge all the errors into one Bier domain, right? So only in this figure, just in this figure, R1 and R2 and the RM, RN, and RXR, RY will be the BFIR and the BFER. So the R3 and R4 needn't to be the BFIR or the BFER. They just BFR in the forwarding plane. So we use the advertisement for prefix redistribute. It's just work on this ABR and redistribute the prefix in this area into the core area, right? So when the RM and the RN's BFR prefix are advertised by the R3 router, it can just advertise the summarized route into the core network. So it's just the control plane unicast advertisement. It's just an extension to IGP.
So as long as the summary and the BFR IDs in these access areas are flat, so if your OSPF, let's call the bottom left side or area 1. So if you have BFR IDs that are very sequential and flat on that area, then it will work because you have the BFR ID range. But if your BFR IDs are not flat and not sequential, in that case, you need to go one by one, adding these CLVs, right? That would be a large packet going back and forth, right?
It's so I think it's a challenge for the. It's not a challenge, sorry. It's just a configuration or administration requirement. So you may configure the BFIDs in one area and with not continuous range for it. But it may lead the advertisement complicate in the R3, but it can do, right? So if you can configure this with a thin range or just a little range, and it can be advertised only few minutes, only few sub-ranges. So it may work well in the network. So it depends on your configuration on the BFID. So we suggest that you can configure the continuous BFID in one area. It's the most efficient way to do it. But if you don't, it doesn't matter. The R3 can also advertise it into the other areas. So it depends on your deployment.
Jiro from Huawei. Continue last question. I assume that the border router that is R3 or R4 in this picture, it should support beer forwarding, right?
Yes.
Yeah. And the R3 should advertise its own BFR ID and its own Bier encapsulation. That is the Bier label together with the imported BFR IDs into the area.
Let me clarify it. We know that if we build the whole network into one Bier domain, there's no need to assign BFR ID for R3 and R4. So R3 and R4 just flood the IGP extension in the network.
Right.
Yeah.
I got your meaning. R3 and R4 don't need to configure a valid BFR ID, but
Yes.
it has to advertise the Bier encapsulation
Yes.
sub-TLV. And
Yes.
this sub-TLV is under the Bier information sub-TLV.
Mhm.
The Bier information sub-TLV has the BFR ID, either valid BFR ID or invalid BFR ID of R3 itself. That information, including the sub-TLV and the sub-TLV, is completely the same thing as RFC 8401.
R3, I'm not sure I catch you totally, but R3 and R4 will play the same role in the one area flooding. So it's the same function defined in RFC 8401 and 8444.
Okay, just to come back to my comment, is that the same sub-TLV and same sub-TLV should use the host prefix. That's my further comment.
Just as I said, if the ABR do the prefix redistribution one by one, so the R3 will advertise one prefix of one node. It can do the same thing with the existing IGP extension. But if R3 would like to advertise multiple prefix in one advertisement, such as summarized prefix, you should carry the associated BFR IDs of the AG routers. So that's our solution.
Hi, Cisco. Maybe can just help clarify. So the summarization is only an optimization, right? So you can just flood those things right through, then they're one-to-one.
Mhm.
And at the end of the day, it's not really more than 256 updates anyway, right? So, but if you do summarize, then that ABR will put its own loopback address as the BFR ID,
Mhm.
right? So it's not that complicated, I think.
Yes. It's not complicated. It's just a smart extension.
This is Stig. So, Stig Vanas. So, do you allow sub-TLVs here? Would the existing Bier sub-TLVs also be, possible to use with this? As an example, at least the first that comes to my mind is like MTU, for instance. If you do like this MTU sub-TLV for a Bier prefix, it would be useful to do that here as well, because you can say this is the MTU for the entire domain. But I'm just wondering, the existing documents that define the Bier sub-TLVs, are they strictly saying that they can only be used with the Bier, the existing Bier sub-TLV?
No,
Or can
we
you also
will
use
come
this?
MTU extension.
Okay.
Yeah.
No, but anyway, though, I feel like it might be useful to allow certain sub-TLVs that we have for the current Bier sub-TLV to be used with this. I don't know whether that requires some kind of updates to some documents or something.
Yes, we can do it in the future version. Thank you.
One more, we got to move.
One more comment, General. I just following my comment before. I think use the summary route may work in some cases, but it should be noted that it needs to update the Bier architecture of C2, because that is required in the Bier architecture to use an IP address.
Sorry, in IGP, let me say that, just like I said, the IGP usually use summarized prefix
There
across
is
areas.
text. There is
Yes,
text in
it's
the
a
RC.
traditional function.
Yeah, architecture RC. I can point it that out.
So
Yes.
let's move this one to the list. We're over already. I don't think it's as complicated as we're getting at, but I think we're moving towards some commonality. Let me just address the important part of progress here. Who's read the draft? All right. Who thinks this should be adopted? Right. Okay. So we're in that same queue. So we'll load that out immediately. In fact, I'll address our secretary and see if we can get this thing moving.
Thank you. I will do it.
All right. Thank you, Sandy. Pardon me? Say it again.
Help me understand what consensus we decide.
Oh, I'm sorry. Yeah, it was the majority of the room. I mean, I saw probably a good 40% of the room with the hands up and I don't see anyone whose hands up. Let's do it again. Who read it? Keep your hands up. Who thinks it should be adopted? Keep your hands up. All right. All the readers think it should be adopted. There's a good dozen at least. That's pretty good for a doc.
Thank
All
you.
right. Excellent. Thanks, Mike. Thank you, Sandy. All right. Back to Lagenda. PIM signaling and yeah, that's. Oh, you're doing both these. You're doing PIM and MLDP signaling both, right? Okay. Normally I put the name on top. I get messed around. So PIM should be first. PIM signaling. Powered by a V8.
So Human Goli Nokia, we uploaded the version 8 or the VA, and there were some good comments on the working group with regard to this draft. We added 3 new sections or 3 new clarifications. One is on ECMP. Basically, what we are saying is that on the IBBR, when you try to find the EBBR, whether there are multiple EBBRs, you can actually look at the CSG and try to load balance your PIM signaling over multiple egress BBRs. So the next one was, there was a comment on the joint attribute address family. We clarified that that address family is actually the PIM packet address family that is arriving on the ingress BBR router. And that's the one that we're actually passing through the PIM signaling. Next slide, please. And last but not least, we clarified the PIM SM. We put a comment in there that it's going to work nicely with the static RP or embedded RP for IPv6. But when it comes to the more complicated SM or ASM functionality like BSR or auto discovery and all these other type of SM mechanism, this draft will not work nicely, and we probably need another draft in the future to address these concerns and these challenges. So this is the latest version. Next slide, please. So where we are standing now with these comments, we are wondering whether there is any other cavities in the draft. And if there are no comments, questions, I think we've done last call on this draft twice. So we're wondering what's the next step.
Who's read in its current form? All right, keep your hands up. If you think it's ready for last call, keep them up, drop them otherwise. Yeah, we've addressed those. Excellent. So another one, this is going to go back to the list as well. I think the 2 week may have come up, we've revved again, just for clarity, we may have accelerated. So we'll go on draft by draft based on history. If you've gone through 2 or 3 like this, we're revved and got solid consensus on it, we have to start over again. But which one? This is PIM signaling. Yeah, we should probably at least clear it with the PIM working group as well. Do you think there's anything issues in there, PIM group chair?
As far as I did, as Stig, I did read the draft pretty carefully, not this version, but the previous one. And I think it should be pretty good from PIM perspective, but it's great to get, of course, review in the PIM working group. So, so I would say I can send an email to the PIM working group, just say there's a last call in Bier, and please go and have a look at the draft.
Let's synchronize. We'll do our last call together.
Yeah,
and then
sure.
we just follow up. Okay,
Yeah.
perfect. Thanks, Steve.
Mankamran sir from Cisco. So just a question, will it be third full last call or it will be short last call?
Pardon me?
So this will be third time last call. So will it be full-fledged 2 weeks last call or
No, I
short
said
last?
we could accelerate this,
Okay.
cut it down. I mean, maybe if we get more in the PIM group, but this is one that has been discussed extensively. We've edited along the way. I think we've got this to a clean point and ready to roll. All the players have been reading and following, so it's not like we have to wake people, except maybe those in PIM who haven't seen it. So I think accelerated would be fine. Thanks. You're in the next one. All right.
Yes.
What we should do is watch this. See that? See that? It was impressive, huh? All right. Just in case
Magical.
you're following along. Pardon me?
I said it was magical.
Yeah, it's incredible. All right.
Okay. So this is, I want to use my words very carefully. I was going to say extended PIM signaling for MLDP, but I know there's I'm going to get a slap on the wrist for that. So this is MLDP signaling over a Bier core. Basically, it's the same idea again. What we are trying to do here is we are trying to extend any legacy multicast protocol over a Bier core without actually affecting the access legacy multicast protocols. It should be a very smooth upgrade when you grab a segment of the network and you decide to go to Bier. We shouldn't affect any of the software upgrades or any of the functionality on the legacy multicast protocol. In this case, it's the MLDP. So basically what we are doing is that we are using RFC 7060, which is TLDP, and upstream assign labels to assign a label in the Bier core. And we stitch that label, the upstream assign label, which is assigned by the EBBR actually, to the MLDP downstream label. And that's how we actually complete the solution of signaling MPLS, in this case MLDP, through a Bier core. So there has not been many changes in version 1. There were some comments which were, asking us to clarify some aspects of it in the draft. Next slide, please. So one thing I added was that I added ECMP case for this also. So the same thing on the IBBR, you can look at the route and the OPEC, like the FEC that is arriving from downstream, and based on that FEC, you can actually load balance your point-to-multipoint tunnels over multiple egress BBRs. Next slide. So on the EBBR procedure, again, it's the same as it was on the previous draft. I'm not going to go over it again for the sake of time. Next slide, please. And on the data path, we did not do any changes compared to the last time that we presented. So again, for the sake of time, I'm going to skip over it. So where we stand with this is that I think we have multiple players on this draft, and we are asking for working group adaptation to make this draft part of the working group too.
Who's read the draft? Keep your hands up. Who thinks should be adopted? All right, you got solid support. I'd say 8 and 8. Thank you. Number 4, Mr. Stig. That doesn't download. That doesn't load. That doesn't fit.
Yeah, hi. So this is about the Bier extension to IGMP and MLD. So as you know, we've been discussing about an IGMP or MLD overlay for Bier. So kind of similar to the PIM signaling we just spoke or discussed. If you want to use IGMP or MLD as an overlay, and as we figure out with PIM is that it's good to have a way of identifying exactly who the receivers are, like who are the Bier egress routers, what I should say. Basically, when you receive a PIM join, how do you know exactly the BFR ID and so on, or who the join came from? And also for IGMP MLD overlays, we want a way of identifying who sent that IGMP or MLD report and who wants to receive. who is the Bier receiver. Anyway, in order to do this for IGMP or MLD, we need to extend IGMP MLD messages, and we don't really want to make any changes to those protocols unless we have to. But I think there's an easy way of doing this. So this draft, it does try to do this in a generic way by having like a IGMP or MLD type extension. And because it's generic and it's kind of a new thing to extend IGMP or MLD messages, I think this needs to go to the PIM working group that is responsible for those protocols.
Let me just address that. I think the conclusions need to happen there. But in the same way, I mean, this is, Alvaro just addressed this to you directly, the same way with ISS and OSPF, those changes need to be made in those groups, but the change request and the information about what needs to go in it came here. So we did the work here, and then we brought in the working group to conclude the work, basically take it on. So I think, I mean, Stig, you're the chair over there. I mean, do you think there's enough information there to complete it? Should we adopt it here first, progress it, and then move it over?
Right. At least right now I'm presenting this in both working groups, and we'll see what people think. But but I would say when it comes to OSPF, for instance, there already was a well-defined way of extending or defining new types. But in this case, there are no other extensions done for IGMP or MLD, and we also create a new registry and stuff. So I feel like it's a more radical.
Okay, it's an architecture shift in some way for the protocol itself. All right.
All right, let's go to the next slide. So the nice thing is looking at IGMP version 3 or MLD version 2 RFCs is that they all discuss how you can have additional data in IGMP MLD reports and queries. And what they say is basically if an existing implementation receives a message with some additional data, they should compute a checksum of everything, but they must ignore whatever additional data there is. So that means that if we somehow put some extension there, existing implementations should completely ignore those extending the bytes or whatever that might be at the end. So I think there is an easy way of doing this. Of course, we don't expect also like IGMP MLD implementations to be updated overall. The key thing though is, like in this case, you only want this for Bier encapsulation. So the only devices that would need to be upgraded to support this thing would be Bier ingress or egress routers. But if somehow those reports or queries would leak, existing implementation should ignore the extra data. I think the main question in PIM working group probably will be, is it safe to modify IGMP or MLD, and is this a slippery slope that people want to extend IGMP MLD for other purposes as well? But we'll see what happens with that. Okay, next slide. So this is what it might look like. So you have the existing IGMP query format, but then at the end there you have some additional data. And what I'm trying to define is an extension type and then the actual value. So the idea with the type, I guess that's on my next slide. Let's go to that. The idea with the type is that if we, for some reason, end up having extensions for some other purpose as well, we can tell them apart. So what I want to say is, if an implementation supports extension and they support the specific extension type, then they process that according to the specification, like this draft. If an implementation doesn't support the specific type or extension at all, they would just ignore that extension and process the IGMP MLD message just like they do today. But if you didn't have this extension type and someone also did some extension for another purpose, then implementations might accidentally try to parse it and treat the data in the wrong way. Okay, yeah. And apart from this draft, I've updated the MLD overlay draft. and basically saying that any IGMP MLD messages sent Bier encapsulated must have this extension. We mostly need this for reports so that you know exactly what the Bier set should be when you forward multicast data. But I think it could be useful for like logging or other purposes that an implementation can know, for instance, where a query came from. And just as an implementation thing, it's probably easier to just always do this for all messages rather than treating queries and reports differently. That's something that we can discuss here. So what I'm trying to do here is one document, maybe in the PIM working group, that focuses on why do we need to extend IGMP or MLD and what's a generic way of doing it, while the actual use of this would be in this working group and for this overlay draft. One thing we could consider, for instance, too, is right now the exact extension type with a value, the TLV canal, is in this draft. But we could potentially, move this TLV to the overlay draft and just have the extension with a registry in the PIM working group.
Gotcha.
But we'll figure this out, I think. We'll have this discussion with PIM working group too.
Excellent.
I hope some of you will be in the PIM working group later today when we'll just discuss this.
It's actually all here today, so we're just going to lock the doors and spend the rest of the evening here.
Yeah. All right. That's it, I think. Okay, yeah, so this is the actual extension that we are using for Bier, and maybe it could be defined in this working group. We'll sort that out. Yeah, okay.
Gotcha. So the BFR prefix is actually the IP address of the origin of the message?
Yeah, so it's basically the Bier originator.
Right.
Or it's the same info that you put in the PIM join attribute for the PIM signaling.
Right.
Or the sub
Okay.
MEPN PTA. Yeah. Okay. I think that's it.
It is it. What's the status of this? Well, you actually mentioned two drafts here. You're going to present.
Yeah, so
them
the
both in-
IGMP MLD overlay draft,
Yeah.
I would say that's basically done, but we need to conclude on this though. You
Right,
know,
it's got to point to registry, it's got to point to the extension. Right.
yeah,
okay.
and also whether maybe the specific new TLV canal, whether it should go, which document that should be in.
Actually, this is encouraging because for once, one of our documents is actually being held up by another working group. It's the other way around. All right. Excellent. Are you in the next one too?
Yeah,
Yeah,
this
you are.
one more.
All right.
All right.
Was there a slot
so-
to ask questions?
Yeah,
Oh,
sure.
You
Sorry.
have questions, go for it.
So the word PIN should be removed kind of from the title, right? Because that's the only.
If it's a PIM working group draft, then
Oh, that's why it's.
Yeah,
there.
yeah.
Gotcha. Okay. Yeah. So I was just wondering from the deployment thing, right? So is it kind of we still have this with Bier because we started with IGMP? Because if I'm now trying to explain to somebody why he would want to do the IGMP overlay as opposed to using PIM, when would this be preferable now that we have the PIM document as well? Because every edge router that's doing PIM obviously also supports IGMP. So
Can I address that? It seems to me if you've got host connected networks, an IGMP message is basically that message now originated, gets copied up as state. It's an easy mechanism. Why would you do PIM? If you had connecting PIM domains, PIM messages coming through and propagates. I mean, that's an easy topology answer. Other than that, it's religion, because if you're going to use that just as membership signaling, independent of what your edges are, yeah, I'm not certain why would you pick one over the other.
yeah, and
well, I think it's a lot more natural in PIM to have basically this concept of the RP for ASM or so. I mean, this one to me would only be good if I really want to try to kill off PIM and just simplify just for SSM, right? So, I mean, that would be my first thought of when this would make sense. All I'm saying, right, if there is any chance to give, guidance, if people look into, we can only implement one of it, PIM or IGMP, right? So
first, right? So all I'm saying is we're giving so many alternatives, and we want to make the Bier successful. So how do we what would be our guidance if people come back and say we can't implement everything at once?
Use BGP.
Okay, two things I would say at least. One is, if you are running Bier like end to end, like all the way to the edges, you don't even need a PIM implementation on the routers. But also, I've done it myself. It's quite easy to modify an existing IGMP.
I didn't mean that you need to answer it now. All I'm saying is I think pointing to the other document and giving guidance.
No, I agree. It's good to have some guidance for people. Sure. Yeah. All right. So this other draft. So we have RFC and PIM for this way of flooding source information throughout a PIM domain. And the idea is, it's described here. The idea is it's a little bit like BSR, but it's like source information instead of RP or group mappings. So the idea is when a first up router learns of a new source, instead of sending a PIM register to an RP, it would originate this PFMSD message. And that message is kind of similar to BSR. It's like forwarded hop by hop throughout the PIM domain. And the idea is you don't need any RPs or anything. So a last sub router, a router with some receiver interest, can just join the S,G immediately. So we have this for PIM today, and it would be great if we could work with Bier as well. Basically, if you have Bier in the middle of a PIM domain, like for the PIM signaling, it would be nice if these messages could make it through the domain. And that means that if you have, maybe go to the next slide. So like in this case, this cloud in the middle here is, there's 3 clouds. The middle cloud is a Bier domain. And then you have PIM domains on each side. And like with the PIM signaling, we would like to send PIM joins through the Bier domain. But if you have deployed PFMSD with PIM, then basically you need somehow to get that source active information to make it through the PIM domain, through the Bier domain to the other side, so that you know that you should actually send a PIM S,G join. So main purpose of this draft, or one of the main purposes, is to just make sure that PFMSD messages can make it through the Bier domain. So they basically are flooded, not within just the PIM domain on the left here, but they make it through to the PIM domain across the Bier domain. Next slide, please. But this draft has an additional extension. It's not required necessarily just for the base PFM functionality, but one of the issues with the PIM overlay is how do we determine where to send a PIM join? I know the PIM overlay draft, PIM signaling draft has like 4 different ways of doing this. But I feel like this is in some ways an easier way of doing it. But at least the proposal here is when a Bier border router between the PIM domain and the Bier domain passes this TLV into the Bier domain, it takes the S,G hold time information that is already in PFM, but it adds a metric to that. So the idea is that these border routers can signal how close am I to the source. And then when these messages reaches to the right side there to the BFER, that can use this information if it wants to join and determine which router should I join towards. So I think this could be quite useful for the PIM overlay as well. By the way, in this case, there's no RPs or anything. That's the part of the reason to use PFM. So to be all S,G joins. And the rest here is just defining these new TLVs. It's basically when a Bier router is forwarding a PFM message into Bier, it identifies itself with a subdomain BFRID and that stuff. And then on the next slide, there is this other thing where basically you can associate the metric with source and group information. I think that's it. Maybe there's one more slide at the end. I know it's really hard to read this, but it's not that important. important. The main thing is that you associate a metric with the source information. I presented this here once before and didn't get much feedback last time, but hoping to get some comments.
I have to admit, I'm afraid to comment because I'm still trying to get my head around what the intent is. I mean, you said to make sure the message got through the domain. Oh, that's part of it. It's not just by getting it out the other side.
Yeah. So
it's just something the domain's doing with it because.
So two things. One is if you have Bier in the middle or between two PIM domains, and you want to make use of PFM with PIM, then you need
make use of it where at your edge.
Okay, let's say that someone has deployed PFM for PIM.
Sure.
And then they decide later, let's upgrade part of our network to use Bier. Mm-hmm. Then for PFM to still work, you need the messages to pass through the Bier domain.
Through.
Yeah.
Is there any additional information within the Bier domain that's being extracted from that information in the packet?
Right. So I would say the minimum functionality is for those messages to just be encapsulated tunnel through Bier.
Just getting through.
Yeah, that's sufficient for the base functionality.
Right.
But the other part I'm proposing is adding these new TLVs could be useful for Bier routers to decide where to send the PIM joins. Basically, who is closest to the source. And we could come up also with some kind of hashing or whatever if the metrics are the same or something. But.
Go ahead, Sandy.
That is on LTE. It works for Bier overlay, right? It's used to collect the SG information across the Bier domain, right?
Yeah, so I would say it's basically if you have PIM and you have a Bier in the middle and you're deploying PIM signaling with Bier, then this extension can be used for the PIM signaling to decide where to send the joins. But also it okay, so let me put it this way.
I got it.
If you have deployed PFM in PIM to begin with, and you decide I want to have Bier in the middle, then we need this for PFM to function. But the second part is if you deploy PIM signaling overlay, then this can help you with determining where to send the joins, what the Bier ingress router should be.
Okay. The second question is about the advertisement, because I think if my understanding is right, you should send this message from the BFIR, the egress router, which is near to the source, right?
So
So
I know people using ingress and egress in slightly different ways.
Messenger data.
But you see on the left side here, these two routers are closest to the source.
Yes.
So we want this router on the receiver side to determine which of these should it send the PIM join to.
Yes. My question is, when the BFIR, the egress router advertises the message, what destination will it be filled in the Bier encapsulation?
It's sent to all, it's flooded, it's sent to all Bier routers.
Broadcast to all the routers, right?
Yeah, similar to IGM PMLD overlay, you just set all the bits.
Okay, I just confirm it.
Okay.
Right, thank you.
Hey, Pop.
Allora, Tana, Featureway Technologies, speaking as an individual. So I may be completely lost here. You're getting the metric from the AGP in the Bier domain, true?
So this guy will use the metric in this domain on the left side here, whatever IGP metric it has to the source. Yeah.
Right, but as this information goes through the Bier domain on the other side, that metric is the metric through the Bier domain. So the question I really want to ask is...
Okay, so when you receive... So the TLVs are not modified as they pass through the Bier domain. So when this guy on the right receives the message, it will contain a metric that was seen by this guy over here. So I guess what you want to do is more or less maybe look at what is your metric to this guy across the Bier domain, and add that to perhaps to the metric. If you see what I mean.
Is that, yeah, I understand. Is that what is specified, or?
Okay, what it says currently, I think, is just join whatever is closest to the source here. But yeah, it makes sense to consider the metric inside the Bier domain.
Okay, so the real question that I have is, before when Sandy talked about her multiple domain things, you asked if you could pass through that distribution point other TLVs, maybe like this one, right? Of course, as you pass through that distribution point, you're going through multiple areas that have different metrics, potentially even different routing protocols, right? So it sounds that if you were to pass that through that point and use the metric inside the Bier domain, that it would be kind of weird, right? Because maybe you have OSPF here with a metric of 20 and SIS with a metric of 2000 on the other side. And then your actual PIM cloud there is, I don't know, something else. So what do you do? And I know that Sandy's draft does not even know what your draft yet, but from the support earlier, it sounds like.
Yeah.
So there's I don't know the answer either, but there's a functionality in BGP called, I think, IETF, correct, which tries to do the same thing. It tries to carry a metric across multiple ASs. And so it's called the accumulated IGP metric or something like that. So maybe look at that, because I think they did it on purpose so that you could have multiple IGPs in different places and then sort of accumulate the metric. Because if you want the closest, right, the closest is not always going to be whoever gave me the route, right? It might be somewhere else, and it may be that one goes across the network in a crisscross or something. So take a look at that.
Okay, yeah, sure. Okay, thanks.
Just for Sally Zhang, ZTE, just for our question, we think that we will get the metric from many ways, just such as IDP or BGP or something else, and maybe we can configure with by the administrator to configure the metric to across the ASS. So maybe we can add a section to explain it in the draft, right? Yeah. Thank you.
Yeah, I would also say one thing to consider is, I mean, I haven't thought much about this, but could potentially, just have a simple draft that just defines the basic PFM over Bier, which is sufficient for just the PIM functionality. This stuff with the metrics and stuff, that would be, potentially something additional if we feel it's useful, but need to think more about whether, we need to do that or not. Yeah.
Any other questions? Where are we in status? Oh, we're dead there. All right.
Yeah, right. All right. So I guess I'm just happy you guys want to read the draft and give me feedback, get some discussion on the list, and I'll think more about the metrics and
Okay. And as you mentioned, maybe split them. Right. If you needed the compliance to get the message through the domain on behalf of PIM, we should probably separate those as separate.
Yeah.
Okay. Excellent. Thanks, Stig. We got Flex Algo. Pardon me? Just say boop.
Sure. Good morning. Mankamna from Cisco Systems. I'll be talking about Flex Algo for Bier. And in the current 0th version of the draft, it is more of problem statement that what we are trying to solve. So we have seen many requirement where network has been sliced using IGP Flex Algo, and each of the slice has different kind of capability. It could be maybe high bandwidth, low latency, or anything else. And how are we going to use Bier, or how are we going to use Flex Algo in the Bier domain? That is what this document is intended to talk about. And right now, one of the mechanism, one of the mechanism which we are thinking about is having subdomain per slice or per IGP algorithm. And we will be using or extending the procedure defined in the Bier bar IPA draft, and which will handle this mechanism. And it is just, for example, it's showing that each, in case of MPLS data plane, you get label per subdomain or per slice, and it can be used. So IGP extension will be used to distribute these information. So that's all, and the more detail will be added for the next IETF with all the related extensions.
Human going Nokia yet? This is definitely interesting, right? Something that we need to definitely work on in the Bier working group. And as we had conversation previously, I can see the subdomain fitting very nicely because it's just the way that Bier is designed. The label, I wasn't sure if I could get my head around it. Like, to me, like a label is a subdomain concept anyway. So with that one, I think we need to do a little bit more thinking. But yeah, definitely something interesting here.
Yeah, Tony P. Yeah, so this is just the right coupling, the way it's supposed to be used. This how the algorithms are managed is not that important. You have this bar and the IPA concept to like decouple all of it and run a completely different computation. Yeah.
Cisco, with maybe clarification. So the label just describes the BIFT ID, right? So you have this combination of subdomain, set, distinct length, right? That you assign a label to that combination. Yeah. That's what it is.
Maybe my question has been over by the previous presenter, and because we know that Bier use IGP as the underlay protocol, so we know that FlexEgo has been implemented in the IGP extension. So we think we just can use this the IGP extension, the underlay, to achieve the a goal for the registration. That include the bandwidth or something else, right? So I'm not know. I don't understand if much more work should be done in Bier itself, right? You just follow the IGP of calculation SPF calculation for the FlexEgo. So we just use the result, and if we really need some extension in Bier itself to support it.
So IGP FlexElgo extension is going to give you the slice, but how are you going to inject from the ingress at which path it has to go?
So you will there will be a mapping from the subdomain or something else with the FlexElgo.
That's
right?
exactly it is.
Okay.
Talking about.
Okay. Thank you.
Thank you.
Any other questions? So who's read this draft? We had one called Mike saying this is work should be done. Who thinks this should be adopted? Picked up in the group. Same hands. Another 6 or 8. Excellent. All right, we're bouncing here a little quick, which is nice. And we are on EVPN. Right there?
Yeah, I think it's my mistake. The draft name is no longer that.
Oh.
Yeah, anyway, it's...
I just posted when I get them.
My bad. Anyway, good morning. Jorge Rabadan presenting this on behalf of my authors. Jeffrey has presented this a couple of times already. And the idea is to have Bier for EVPN services. So after RFC 8556, it feels only natural to bring together the beauty of EVPN and Bier. So this is about having Bier as a provider tunnel for EVPN traffic. EVPN, not only IP multicast on EVPN, but in general BUM traffic. It's very similar to Bier for MVPN, and actually some of the text is taken from RFC 8556. There are some EVPN-specific aspects that are described here, things like leaf tracking, some stuff related to data planes and how you handle multi-homing and segmentation stuff. So we go to the next slide, please. Yeah, so the way we encode the Bier information, there are no surprises here. It's pretty similar to MVPN. We put everything on the PTA and the PMSI tunnel attribute that we advertise, along with IMET routes and SPMC AD routes, which are the equivalent routes to MVPN, IPMC, and SPMC AD routes. So same kind of information. From an EVPN perspective, a Bier tunnel is just like an aggregate tunnel. So we need an extra piece of information for demultiplexing the traffic at the egress. That goes in the label. That's an upstream assign label by the BFIR, and it's identifying what to do at the egress. Pretty much the bridge table, if you have an EVPN service, or if you have an ASBR, the PMC. You also have some flags that we use for leaf tracking. If we go to the next slide. So yeah, about leaf tracking, we use, if you have pure layer 2 bump traffic, the IMET routes are enough to track the leaves where you need to send the information. If you have IP multicast, if you are snooping and using proxy and the EVPN services, you use the SMET routes, the EVPN routes type 6. In some cases, you may want to do some optimizations if you don't want to send SMET routes, for every single flow. And in such a case, we also have in EVPN SPMC routes and leaf routes, so that you can do some tracking. So you can have some kind of mix between, an SMET per flow, or then you can track, depending on how much flooding versus control plane routes you want. Next slide, please. The other aspect that we are looking at in this draft is because EVPN works for IP overlay tunnels or MPLS tunnels, we're also defining how to, how the data plane works with Bier. So in the first case, if you're using IP overlay tunnels like VXLAN, MVGRE, or Geneve, basically you will have the Bier header, and immediately after you will have the VXLAN or MVGRE Geneve header, and then you will have the payload, which is always an Ethernet frame. There is no IP UDP header before for instance, the VXLAN header, and the reason why is because you already have in the Bier header, the information about what the next header is. So we save some overhead with this. And when we use this along with all-active multi-homing, there is something called the split horizon that you need in all-active multi-homing in order to avoid loops for bump traffic. And here, because in the Bier header you have the BFIR ID, so you know what the source of the traffic is. So you can apply a split horizon, just in the same case you would do with other tunnels. In the case of MPLS, we have the Bier header, and immediately below that you have an MPLS label to identify the bridge table, and you may have yet another label to identify the source ESI of the packet. That is also used for split horizon with all active multi-homing. Next slide, please. So the draft also talks about segmentation, which may be used in certain situations. For instance, when you want to use different tunnel types in different areas or autonomous systems. But you can also use this in a larger Bier domain to divide it into multiple smaller subdomains. And when you do this segmentation on the ABRs, ASBRs, as usual, you need to change or to update the PTA on the IMET or the SPMC routes. So next slide, please. Whoops, sorry about that. In the slides, it was looking okay. Anyway, so what the title of this slide says is what is new in the revision 02. So what we added, there was a discussion on the mailing list, and basically, when you are using this along with IP overlay tunnels, and you want to use PHP, a couple of slides ago, I was saying that for instance, for VXLAN, we don't use an IP UDP header after the Bier header. However, if you do PHP, basically you remove the Bier header as well, so you may end up with packets without Bier header or IP UDP, and just with the VXLAN header getting to the egress node. So the egress node wouldn't understand what that is. So what we are saying this revision of the draft is, if you are going to use PHP, you must add an IP UDP header before the VXLAN header. Now, once you do that, you need an IPDA in that IP header. So which one to use is something that you can statically configure at the egress P so that you know what to expect. Or we added this auxiliary information on the PTA where you can actually add a tunnel encapsulation TLV defining what the IPDA is. It's an IP multicast address. So you have both options pretty much. Next slide, please. So next steps is to request for feedback about this version. And after that, we really believe the document is ready to progress working with last call.
Who's read the document's current form? We've got, keep your hands up. Not too many. All right. Who thinks it's ready for last call based on those who read it? You got a comment. All right, good.
Mankamna from Cisco Systems. So I'm not sure I followed it in BESS. So by any chance we have presented it or took this document to BESS as well, because it's more of EVPN construct. So when we are doing last call, it might be good to involve BESS as well.
Yeah, sounds good. Makes sense. Thanks.
The previous slides, please turn.
Previous slide?
Turn back, yeah. I see you mentioned the IDR tunnel encapsulation draft here, right? So what we will do, we will inherit all the encapsulation types from this draft, or we will define the new type for this tunnel. Because I only see 3 tunnels are mentioned in the draft right now, such as the GNIV and the VXLAN and the MEGIE. But we know that there's many tunnel types are defined in the tunnel encapsulation draft. So if we will expand this draft to include all the tunnels here, or we just only use the 3 types listed in the draft now.
So the new piece of information we are interested in is really the IP destination address, because normally in EVPN you already send the IMET routes or the SPMC routes with a BGP encapsulation as extended community that is telling you whether the tunnel is VXLAN or MPLS or whatever.
Yeah.
So I do not think that is necessary. So, but yeah, I mean, in theory, with any IP overlay tunnel, you could include the code point and the IP destination address. So
just this is enough. I'm not very sure, because we know that in the IDR tunnel encapsulation draft, we will expand all the tunnels information through the community extension, right? And it will be signaling by BGP protocol. And it can also be used in EVPN right now. But because maybe we can only use some the listed 3 types for the advertisement and use it for the encapsulation. Because the main idea of you is to use the tunnel encapsulations for the data packet right now, right? You want to use the tunnel encapsulation for the data packet, and there's many tunnel encapsulation function can be used to encapsulate the data packet, right? So, so my question is, if we only define 3 types tunnel here, so if we only support 3 types after the Bier header, because it can be registered in Bier next protocol. field, right?
So
Mhm.
this is mainly based on the work we've done on BESS. In BESS, we've defined EVPN documents for IP overlay tunnels and MPLS tunnels.
Oh.
For IP
Oh, I
overlay
see.
tunnels, it's mainly RFC 8365 and defines VXLAN and VGRE. There's also a document for Geneve. And now we also have a document for SRv6. So those are pretty much the IP encapsulations. So that's why this draft is focusing on those, right?
Okay, I see.
So if you're missing something, yeah, you're of course welcome to.
Because the other encapsulation can be inherited from the IP or UDP header. You can get the information from the IP or
Sure.
UDP header. Yeah, right.
Yeah, and this
Okay.
this is only optional. You can always, yeah. Of course, you need the IP and UDP header, and then you can always, for the IP destination address, you can always configure it.
Yes, I got it. Thank you.
Thank you.
Alberto Thunder, Routing AD. I'm going to ask actually Sandy's question in a different way. So I think what she means is that the TLV has a bunch of other stuff that you don't care about. So even if it's optional, what happens if the tunnel type is something else? So eventually, when you specify this, please write in the draft what should happen if you receive that TLV with some tunnel type that is not supported.
Mm-hmm.
What should the receiver do?
Yeah, that sounds fair. We can add more text about that. Yeah. Thank you.
Any other questions?
Okay.
We went through the count already, right? We did a count on who read. Right, same guys. All right.
All right.
Thank you very much.
Thank you.
It was like 4 and 4. Yeah. Blue shoes. Are there any blue shoes in the room? No blue shoes? Look at that. Sandals and socks, the German way. Wow. Bing! Thank you, Torles. I knew you'd comply.
Okay, so we have a working group last call since 104. Still looking for additional reviews. Please check it. Last time we were at 103. 03. Now we're at 05 with the review feedback, a little bit more from Dirk, who had already done 03, and a great review from Jeffrey. So right now I think we're standing at 5 approvals to move on. Jeffrey hadn't come back after 05, so probably been too busy and missing here in action, unfortunately.
Just as chair, that thread was just like this week or last week too, right? Wasn't it?
Well, no, obviously more than 2 weeks ago.
Before
I
close.
updated
Yeah,
05
right.
before.
Yeah. Okay.
Yeah. Okay. Next slide. Okay. So basically, in the introduction, all the changes are non-functional. They're all, trying to improve the readability and the explanations given on some of the more complex topics. So one of the things we actually been brainstorming a little bit in Roll was also using Bloom filters. So there is a reference just to related work that had been starting with Bloom filters, and why we're not using Bloom filters here in BRTE. Then people didn't like the word layers for the picture showing, so this is now called components, kind of BRTE controller and the routing overlay, routing underlay and so on. So just using term components. Likewise, a reference to this Bier multicast HTTP response draft that we have describing, HTTP and BRTE as a use case for the flow overlay signaling mechanisms, because that's what we're using there. There was a section 3.4 with the initial big BRTE forwarding example in 02. People said that there was a need earlier in the document to do something. So in 03 we had added bigger, 2 new examples. And so this old stuff is meant to be removed by RFC editor unless, any other reviewer chimes in and says, no, I also want to keep this old example. Next. Okay, so then leave BFERs. So, oh no, now I'm going to kill the remote audience by going here. So basically edit this picture here to explain better the difference between a normal BFER that can be a transit device. So this is basically, you're saying I should try to stay in the cage. And okay, all right. That's okay, so right, so you see, this is what in service provider terms we call a U-turn attachment, where you have 2 PE nodes attaching to 2 P nodes to reduce the total number of links we need. This is the more traditional, more expensive PE attachment. In this case, this PE can be transit for traffic from that P node all the way to this P node. And so that basically means we need to allocate individual bits for these 2 PEs, whereas these being leaf nodes, we only need to attach BRTE bits for the 4 links. Therefore saving bits. So this is now hopefully a lot clearer through the picture. And obviously for these nodes never to become transit nodes, the routing protocol, of course, also has to be configured accordingly, that in case of link failure, there can be no transit traffic through the PE, also a standard way on how in such a network you would do it, because obviously these links are not meant to have enough capacity for transit traffic. Next. So then also the somewhat compressed form of representing BIFT entries for ECMP, what this stuff meant seemed to haven't been clear enough. So through the document where many of these, where they've been expanded into saying we're doing an ECMP over, multiple different direct neighborships, forward connected layer to adjacency, and basically the ECMP is picking based on the seed one of those. So hopefully this is a lot better readable now. Oh yeah, and the hub and spoke added explanation how basically the hub and spoke is kind of a flood optimization, because we've seen a lot of deployments with multicast for TV services where you knew all this program stuff needs to be flooded to all the next layer in the network, let's say the next aggregation stuff, so you can really assign a single bit to all the spoke links because everything needs to be flooded. Next slide. So then the ECMP stuff, obviously, the whole polarization stuff is always the most complicated thing to work through. So the text is refined in 05 now, saying that we don't need to standardize the ECMP algorithm, but obviously it needs to be documented so that the proprietary mechanism needs to be documented so that the controller can calculate the ECMP decision, and there is an example of an algorithm given. So basically when you have a packet and you have an ECMP for a bunch of adjacencies with a particular seed, the most classical algorithms being used in the industry is that you take the entropy from the Bier header, you XOR that with a seed, and then you do a modulo by the number of adjacencies you have, and then you forward it to the resulting adjacency from 0 to n-1, right? So that's basically this predictable form of, modulo ECMP that's done very often, also classical in IP multicast. And the whole point here was to have the seed so that in different stages of this forwarding, you can configure the ECMP to use a different seed and therefore avoid this typical multi-stage ECMP polarization problem that, for example, because everything goes left here, in the next stage it also goes left here, so nothing ever goes on this link, for example. Okay, next slide. Then there was also routed adjacency. So in the introduction, in the beginning, there was an explanation that routed adjacencies are kind of like this, I'm not using the terminology segments from SR, but kind of the line of thought is the same, that you're kind of jumping over points where you don't need to do routing and you're only interested to specify on which kind of node or interface on the next point where you want to continue your traffic steering, you want to come out. And this whole picture seemed in the review from Jeffrey to be too confusing, so I simplified it, just having one stage here, right? You're on one of these ingress routers, you want to get across this, and you have these two different cases, like I want to get into this next hop across one of these two interfaces, so those are 2 bits, or I just want to get into this node, so basically my bit is assigned to the node logically in a loopback interface. So pretty much the same what we're doing in SR. So hopefully this is now clearer by being simplified. Next slide. So then at the end of the whole section 4, which is all these optimizations for the PCE controller in BRTE to minimize the number of bit positions, is this stuff that I was trying to avoid in before, because it's kind of the most complicated one, and that's kind of how can I reuse BPs in a BRTE environment in a general fashion. And the general fashion, of course, is I cannot reuse a bit position multiple times along the same path, because it will have been cleared the first time you use it. But you can, of course, reuse bit positions when you can calculate that they'll always only happen in parallel across different branches of a tree, right? So you're basically saying, here I'm setting bit 5, and then replication happens, and somewhere down here you're always reusing the same 5. So in structured networks, for example, at the edge of interfaces toward different areas, those are kind of replications where you can save a lot of bits when you have it very structured and you're replicating first, and then the same bit will achieve the same kind of traffic engineering further down in each area. So that was kind of added because that seemed to have been a point of confusion in before from the review from Jeffrey. So and then at 410, there is a summary of restating all these 9 types of optimization of the bit positions with a simple paragraph each too. So kind of to close that section. So I overhauled the explanation of the forwarding pseudocode. No change in the forwarding pseudocode, but the idea was to explain the distinction between Bier and BRTE with respect to the fact that Bier, by having these few, the most optimized number of bits just for the destination, will basically have the dependencies between the different replication, that if you're sending out a packet to the first interface for the first bit that you are routing across that interface, you'll be clearing out logically all the other bits that you would also send to the same outgoing interface, right? And that creates a dependency between the replication you're doing. Whereas in BRTE, well, we need to have a bit for the outgoing interface, and that triggers the replication there. And the node doesn't really care whether it's replicated further down to multiple receivers. So more bits needed, but for that matter, the operation of determining a replication to every individual bit is independent of any other bit. So you could, for example, allocate a single CPU core for every bloody bit and perform the execution, the replication in parallel. So that was basically, hopefully the newer text is better expressing that. Next slide. Right, so then I had something like trying in this section 7, which was more operational stuff, to say that the total number of bits we need for the transit hops to specify the path, maybe between 20 and 80%. So then Dirk challenged me, okay, where are the 100 pages of research paper with good combinations? So I basically had to admit that we've done some, on whiteboards as some example, but we haven't really published any good, quantitative analyses. So basically now the text is more weak in here in saying that, the number of bits we need can vary widely based on the topology, right? I think 20 to 80% is good, but, you don't want to write it down if you don't have a good reference. BRTE and segment routing. So there was an added explanation how senders can determine receivers to send packets to in a way that relates to the use case from the HTTP side, right? So in Bier, the sender just needs to know, here are my destinations that I know with a name or IP address, and I know a bit for each of them. So I just OR these bits together, and voila, I got my Bier packet. In the case of BRTE, you pretty much have the same thing, but instead of having just a single bit for every receiver, you have a bit string of the path to the receiver, and then you're ORing these together, and that gives you the BRTE tree. So for the sender, the same type of simple operation. And in before I had included these type of, independent branches type of calculation from the controller. If you have something like Steiner trees, which are more optimized, the sender has more work to do when he adds or removes the receiver because the whole tree changes. But in the normal shortest path type of routing we have, this makes it as easy. So that was the missing explanation here. Next slide. I think we might be, yep, and that is the end.
It's over.
Right. So Jeffrey hadn't come back, but hopefully would be up to 6 votes in that. So any more reviews, highly welcome, so that we can finish the last call.
Yeah, please do. I mean, this has been, this is a part of the process. But Jeffrey had some good feedback, great amendments to it. I want to make sure that we go from here beyond just the two of you talking. Right. So he's got this edited from the last comments that were on the list, primarily from Jeffrey's. So to get the conversation going again, we'll restart the last call, just get that rolling. All right. Anyone else have any issues about that doc? Any questions about that doc? All right. Excellent. Thanks, Torlis. Okay. V6 requirements. If you need to point to the slide, you do. But
You do that.
I got to do this. Yeah.
Okay. All right, so just a quick recap of the purpose of this draft. There were a variety of V6 replication using Bier solutions that have been proposed, and we decided that it'd probably be best to come up with a problem statement draft, which we did, and then the chairs suggested, as the working group agreed upon, is to have a requirements draft first. In this requirements draft, we do summarize the different solutions, but it's not a solutions draft. We will be moving that to the appendix. And there are a variety of solutions. There's, used to provide that V6 replication using Bier. There's Bier Ethernet. There's using destination options. You can put the bit string in the destination address. There's encapsulation. There's encapsulation encoding. There's a variety of solutions. And again, we put that in there, but we just need to focus right now on the requirements. And that's the purpose of the draft. One thing that we do have in the draft at the very beginning, and this is something that we talked about last time, and that is using the term native V6. And that was a little bit of a discussion last IETF, and we still have it in there. That term is also used in the MBOND working group charter. So maybe we as a working group need to decide what exactly that means. In this draft, it just means it's not encapsulated in Ethernet or MPLS. If that needs to change, then let us know. Since last IETF, we've continued to develop the requirements section. We've created a GitHub repository for updates to this draft because of the weirdness going on between the U.S. and China right now. The governments aren't too good of friends, so we put things in the GitHub just to make sure everything's in the clear and to cover our basis. We have removed some solutions with regards to pros and cons wording. We've kind of gone back and forth on this as well. We first were trying to stay as neutral as possible. Then it was recommended that we do provide some pros and cons. And then in this latest draft, we've kind of softened that approach and just let the solutions drafts do their own justification and just focus on the requirements. We provide a little bit of commentary under the requirements, and that may still need to be debated a bit because the authors do have their names on one of the solutions drafts. My name is on 2 of the solution drafts, and kind of to fast forward a year from now, really right now we have 2 drafts that are being actively worked on. There's other proposals as well, but right now there's 2. Correct me if I'm wrong. So for the next rev, and thank you, Tony, for your comments, we will remove all references to SRv6 in the document. We've agreed to that because it was not helpful. It just complicates the things. Rajiv has been telling me and the other authors to move the solution summaries to the appendix for some time, and I haven't listened to him until now, but now I feel I finally am a believer, and we will move those solutions to an appendix. You have told us that those are helpful, and so we'll keep them in there just to give a summary, an overview of the different solutions. But so for those of you that have solutions documents, please review those sections. We would welcome you to be authors on this draft. It would help make this draft progress better is if you authors were authoring this draft as well, so that we're all in agreement on the requirements. And we will further modify the requirements. Next slide. So I've already mentioned the draft purpose. Really, again, our goal is to help the working group come to a conclusion as outside of this draft on which of these solutions to rally behind and adopt. And again, my own bias and conclusion is that right now there's two solutions, and I think eventually we may not want to we may just want to work on those two solutions until somebody else has solutions they have interest in working on them. Next slide. So these are the requirements. We have 12 today, and we will need to further discuss these on the list. That's what's been most helpful. So again, thank you, Tony, in kind of providing some feedback. Maybe for the we can just go through them. We can just go through them real quick. Stand up or speak up. Yeah, if there's if you have an issue with one of these requirements. One thing that, again, that we need to be aware of is that we have these requirements, but we also have some commentary behind the requirements, and the commentary may sometimes be a little biased as I've looked at it. So that's where we have to be careful, and that's where having other authors would be helpful. So as an example, the first requirement, it would be helpful to have a solution that's agnostic to the underlying layer 2 data link type. That doesn't seem to be too controversial. And just as an example, and I won't do this with all the requirements, but like the Bier Ethernet solution is a very clean solution, but it is not agnostic to the underlying layer 2 data link type. So when you're evaluating that particular solution, you can look at all the other requirements and you can say, okay, it maybe provides meets all the other requirements, maybe just not one. So that's something that the working group will need to evaluate. So the other ones, and this is some of the ones that Tony had a comment on, and this 4.2 may need to be rewarded and may need to be expanded into 2 requirements. And that is that it should not require hop-by-hop modification of the source address field and should use an IPv6 unicast address in the destination address. Are you shaking your head because you don't agree with that? Or?
Well, I mean, Tony P. Juniper. So I sent you out comments why the 4.2, 4.3, and 4.11. So thank you for decoupling the SRv6. I mean, we may write, the hop-by-hop loophole that you can change it, right, on v6, or we may not, but it has nothing to do with v6, right? The 4.2, 3, and 11, that leads to a very profound discussion. I mean, Bier is a 2.5 technology. Okay, it doesn't do multiple hops. It doesn't do fragmentation. This is like MPLS. So if we want to change it at an architectural level and all of a sudden go like multiple hops, right, and preserve source addresses, that is a fairly substantial discussion with the working group, because that's what is being sneaked with those requirements. Well, I shouldn't use those words. I mean, those requirements kind of imply a multi-hop architecture, which we don't have. So even the Bier in 6 kind of allows jumping multiple hops, which is like a hack you should not use, but may be helpful. If we go along those requirements, basically all of a sudden over v6, Bier becomes a completely different technology, becomes a tunneling technology, jumping multiple hops. So that's why, but I mean, I spelled it out in the email pretty clearly.
Yeah, you did. Yeah. So as a reminder, the way that we've worded the requirements is this should be something that, as you can see here, should be implemented. But maybe we need to rethink that wording, and maybe there's some other options we can do. Yeah, Jingrong.
Hi, Jingrong from Huawei. Yes, Bier is generally a layer 2.5 solution, but it has been made clear in the RFC 8296. It is allowed to transport Bier in layer 3 or layer 5 or layer 4 or so on. And it is mentioned that I just read the text from this RFC. The action can be fragmenting the packet. Then the procedures of the section are applied in sequence to each fragment. This RFC allows the fragmentation, has considered the fragmentation as an additional function to Bier 2. This is from the RFC. Also, I think I want to share some background why we think L3 solution is required. You know, in China, the IPTV is a basic service for hundreds of millions of subscribers and are running on IP networks using PIM. They are not intended to use any layer 2.5 solutions like MPS and are likely not to use it in the future. And the network is already IPv6 ready. So they require the solution for all the benefits of Bier. So that's my comment. The layer 3 is firstly from the view of service providers' requirements. Yeah, we also think the layer 4 and layer 5 may also be useful and may have some advantages in some cases. For example, may for software implementation using the socket API. But also we realize that it has some limitations as listed in this requirement draft, that it may be difficult to support the fragmentation and IPsec. That's not a very strong requirement now, maybe, but maybe someday we come to require that can you support IPsec? Can you support fragmentation? Then things blocked. So that's my comment why we think we need to build the solutions on layer 3. Thank you.
Very good. Okay, so we probably don't need to run through these requirements, but there's still much discussion to be had about these requirements. We should do so on the list. And I continue to request that others join us as authors on this draft, just so we can make sure our bases are covered. Last slide, which is the next slide. So we originally thought we'd be done by this IETF, but it's apparent to us that there still need to be some work done on these requirements to make everybody happy. It is important to realize that our solutions that we rally behind are likely not to satisfy all the requirements, but I think that's okay, as long as we feel like they're meeting the majority of them. Please continue commenting on the draft. Are there any other questions or comments?
Thanks for taking the work forward and taking the brunt of the conflict. No, the conflict has to be had.
Yeah.
Because it has huge implications architecturally, right? Especially on the security model side.
So we have time. Go ahead and go to the encapsulation graph. Yeah.
Liang from China Mobile. Yeah, I'm going to talk about this draft. This has been a lot of discussion on the list. So basically, what we're proposing is a IPv6 encapsulation solution for Bier. If you go to the next slide, so I'll spend a little bit more time on this one. So the basic idea in this draft, just in case that someone not reading the draft, so I'll spend some time on this. So basically, we're using a unchanged source address for the entire flow, and also to change the destination address by using the neighbor Bier router. So basically, the principle complying with the requirement in Mike's draft, we're using the standard Bier header So that's a basic encoding thing. And we're using unicast address instead of multicast solution so that you can basically go through those n multicast aware node. So I'd like to go through this process with the packet. So if you have a packet sending from A, so you can use the loopback source, and then you use the destination address of B, and then for the node between A and B, non-Bier router says, oh, this is a packet for B, it's just unicast, and then we'll forward it to B. And then B catch the packet and say, oh, this is a packet for me, and that's actually Bier address, Bier destination address of B. So, oh, this is my beer. So I kind of open the can and drink the beer. And when I drink the beer, I actually found, oh, I need to share with two other guys named C and D. So I basically receive the can and put the bit string for D is 3, so bit 3, and then 1. And then I actually encapsulate the destination address of B on the packet as well, and then send to D. And then he can drink the payload. So that's basically the idea. So we use the extension header DOH for Bier header or native encoding. So it's compliant with the architecture, requirements. Yes. So next slide, please. So the few upcoming slides is really the a list of the requirements that we think we're compliant with the current requirement draft. So I'm not going through in details, just this one, basic architecture, doing the, not changing the Bier header, things like that. Next one, please. And so this one, there was the discussion of fragmentation security. So since the requirements are there in the draft, so these native, layer 3 encapsulation of Bier header, yes, it give you flexibility or give the support of fragmentation and IPsec security because you have the header, you have the Bier header in extension of v6 and stuff in the payload. But I mean, if it is not compulsory, then this is, if it is optional, then it's optional. I'm not saying that we have to do this in some way. It just really depends on the requirement, how it goes at the end. Just for information, this is supported by this solution. Next one, please. So yes, so we're actually changing the destination address. I've go through the packet flow in the previous slides, and the source address is not changed by hop. That's basically give you flexibility of also receiving the notice on pin or trace or MTU notice, and it makes things a little bit easier if you want to filter the packet using source address because it's basically the source, the real source. Yes. So next slide, please. I think that's actually, oh, there's another one. Well, yeah, it's basically comply with the listed requirements in the draft. Not going through this. Next one, please. So to conclude, this has been in discussion for quite a long time. So there are we received a lot of comments and suggestions on the mailing list and offline discussion, and we improved the draft quite a lot since the one before last meeting. It was not presented in last meeting, I think. Yeah. So yes, I think in the current draft, the form in terms of a solution, I think while there will be some defect, well, not defect, but the room to be polished, but I think there's no hard defect for the solution. So we think in a form of a solution-based type of draft, it's quite mature. We'd like to, ask for opinion of calling for a working group adoption. Thank you.
Nokia. Yeah, well, I think IPv6 is a hot topic, right? It's the hot potato, and I think, yeah, I think everybody trying to peel it with a different tool, whether it's a fork, a knife. doesn't make it different. I guess my comment here is that sooner or later, as a working group, we need to come up with one solution. We do not want to make unicast mistakes, if I will. So what I'm seeing here is it's very close to Bier in 6 draft that is going on also, right? So I wonder whether we can kind of combine these drafts or work to combine them together. So that's the first comment. And the second part is what you brought up here, the security aspect, IPsec, etc. That's very interesting. So I think we need to understand whether for Bier we want to entertain all these little IPv6 quirks into the Bier, including security, IPsec, because I can't remember if with IPv6 if IPsec is a tunnel mode or transport mode. So all this stuff will come into play from encryption point of view.
Mike McBride, FutureWay. So we as a working group need to decide if we want to start entertaining, adopting these solutions drafts in correlation with the requirements draft, or do we need to wait for the requirements draft to become more mature before we start entertaining solutions drafts? That's the first point. Second point is, as I mentioned, there really are 2 drafts that are being mostly worked on. There's a variety of solutions, but they're just 2. And it wouldn't be, in my opinion, harmful to eventually adopt both of them and then eventually have one draft that we submit to the IESG.
Hi, Cisco. So you are encapsulating the Bier header as is, right? So I don't think that doing that in an extension header adds any value, right? And I agree with Helman what he said, right? So if the Bier in 6, we just sort of remove the extension header. So yeah, I don't see the benefit of that. The other thing I think is too early to ask for adoption, because ideally we want to have one solution going forward. So yeah, I'm not sure if you want to adopt both and then select one. Maybe it's better to do actually that work before adopting, I think.
I think, Chip, just Chair, I don't think there's anything in process that stops us from doing that. We've done it before and things can merge and go. But if we have some foresight of where we want things to go and merging beforehand, it would make more sense. But I don't think there's anything preventing us one way or the other. Go ahead, next Mike.
Hello, I'm Adrian from Taiwan. I think the current approach for encapsulation the Bier string is in the destination operation. Destination option can accelerate the deployment of the multicast in the native IPv6 network. So because in IPv6 we want to decrease the rely on the MPS protocol. So I think it is a good direction to approach. One comment for the kind of solution is because for in country encapsulation we will change the destination address along the Bier wrapper. So maybe there are some difficulty for the OM operation, because the traditional IPv6 transportation, the source and destination will not be changed. So currently the destination will be changed based on the Bier string. So we should consider the OM influence. Okay.
Yeah. Can I quickly comment?
Yeah, if you got comments.
Yeah, I mean, yeah, we can discuss that offline in more detail, and just an emphasis that the destination address plane or field is actually for Bier. So you have your unicast normal packet destination for each of the Bier router anyway. So that's a standalone plane address pool for Bier packet. So yes, we could discuss that offline for OEM.
So let me stop in. I don't see it addressed that this is being dragged in a completely different architectural corner of the world. Okay, you're taking a 2.5 technology and try to extend it to be a tunneling technology and inventing stuff on the fly. If you run Bier, Bier has a full OEM layer, okay? And you carry a BFR ID in the Bier frame, and you have OEM bits, and you have everything. And now you try to replace it with IPv6 OEM, right? And drag a full security model in, because if you run a 2.5, then you have the IGP, you talk to the people, and you know you can trust the next guy. He's expected to send you a packet. Now, all of a sudden, you have the whole v6 addressing that starts to come in. So anybody can basically shoot a Bier packet into the middle of everything, and then random stuff can start to happen because this guy can shoot it 17 hop away with a completely different thing again. This, please, needs an architectural document with all the security implications, OEM implications, and so on, right? You're taking that to a completely different plane, so that the little details of what is node, does it modify a source address or not, are not that relevant. This is shifting it from a 2.5 layer to a complete layer 3 tunneling technology.
Hello, Jinro from Huawei. I think I agree with Holman, and his main concern may be one is that how is the difference of two solutions, and if these two solutions can combine or converge, I think it's possible. There is only some differences between the two solutions, and some in common also. About the security concerns, it's also valid, and the RFC 8296 have been very wide to allow the A over B such solutions, and mentioned that it is desirable to verify the packet is from a legal source. For layer 2, layer 2.5, this may not be the problem, and layer 3 or up has this problem, and we have the using the special IP destination address for BFOD only, and don't open the TCP or UDP probing for this address. This may be helpful for the security. And another one is that from the architecture we support the IPsec, and this may also help the security.
So we're running close on time. We'll take this as a thread, but I want to encourage constructive comments, like when you have an architecture decision you made right there and you said may be helpful. Maybe helpful is not a part of a contributing argument. Show us how it's helpful, and then we can have a conversation from there, right? So just kind of, I'm just trying to focus our conversation around what we're doing. And editorial, just because I'm here. This first slide. Yeah. I know what you were showing here was helpful. This is not encapsulation. This is the basic forwarding model.
Okay.
Simplified. So it'd be nice to start with encap so we can discuss the encap and see what we're doing in affecting a document that's describing encapsulation.
Okay.
And then we can understand what we're trying to do with those bits or vice versa. So just editorial in the future to help streamline the conversation. All right. Who's got the blue sheets?
While you're at the blue sheet, so one clarification. I mean, you cannot do it on a destination header. You have to do it on a hop-by-hop header. You can only change the hop-by-hop header by v6 architecture. You cannot change the destination header in the intermediate hops. So that confused me, just as as observation.
Any other questions on that? All right, so we're wrapping here. Thank you, everybody. We've got a lot to follow up on the list. Sandy, if you can come up real quick before we roll off. Any with some questions is great. The rest of you, enjoy your lunch. Thanks, everyone.
Everybody, make us popular. Come on.
Look at all the autographs we got.
Look at that groupie. Beers, no beers.